All right, welcome everyone today to our third session of the hackathon, the Geo Hackathon that we're hosting here. People are just kind of trickling in. So I'm going to go ahead and get started. And I'm going to share my screen here and introduce you to the fantastic speaker that we have today. Go ahead and share my screen. If you do not see my screen, please let me know. I'll just briefly introduce myself. I am one of the many fantastic organizing committee members for the SPE Europe Energy Geohackathon. That's a mouthful. But yeah, I'm one of many members who are helping to organize the Geohackathon. We are very excited with the breadth and volume of people who have signed up for this. And these bootcamp sessions are really designed to give you the skills and background that you need to really apply yourself when the hackathon kicks off in November. I'm sure this will get asked several times in the chat, but I'll just say right off the bat that these sessions are recorded. We'll be making them available via the Discord channel. And this is the third one. So if you missed 1 and 2 on both kind of a background on the hackathon, Croatia, and Croatian geology, which was Monday, I believe. And then Wednesday, yesterday, was more on the data and modeling side, which we're going to dig into deeper later on as well. But those will be recorded and available on Discord. So today we're going to go through session number 3, which is focused on the geology of geothermal reservoirs. So whether you're a geologist, a geophysicist, an engineer, this is all really important background for us understanding how geothermal systems work. And we're very, very lucky to have Ana with us today. Ana Maria Alexandru, am I saying that right?
Yes.
Perfect. All right. So Ana is from OMV, and we've got her here today as a geologist talking about the geology of geothermal reservoirs again. Ana has a background of 10 years of very diverse experience across the energy sector. This is the case with lots of geothermal geologists. You get a lot of background, a lot of skills coming into play, and that just kind of makes things working in the geothermal space even better when we bring a lot of skills to this. So she has a BSc in geological engineering at the University of Bucharest. Uh, Bucharest, sorry. And now she's as a production geologist at OMV. So she has a large, diverse background in geological modeling and engineering and working across multidisciplinary teams. So these are all really important skills to geothermal. So she's currently working in the low carbon business division. So it sounds like, Ana, your role covers, you're touching a lot of different organizations and a lot of different parts of OMV and bringing in engineers and geologists all together to kind of work on geothermal in general. So we're very excited to have you here. And so I'm going to pass it to you, Ana, and I think you're going to go ahead and share your screen and get kicked off. Does that sound good?
Yeah, thank you, Kathleen, for
Okay, thank you.
Hi for everyone. I will take over. Let me see if you can see my screen.
Oh, and just while Anna's getting kicked off too, I forgot to thank the Geothermal Hackathon. We have a number of sponsors which are working with us too. And so at the end, I'll just do a little shout out to them. But I'd just like to say there's lots of moving parts here, and we're very grateful to have so many folks involved with the hackathon, including yourselves, the participants. So there you go, Ana. Thank you.
Okay. So, hi everyone. Today I will cover the geology part, like Catherine mentioned. As an agenda, I will start with the scope of geological models, and I will try to detail a little bit. Okay, and I will try to detail the type of information that on which we are relying to build those kind of models. I will also discuss briefly about the existing workflows. And in the last part of the presentation, I will be focused on how we can apply our experience as geoscientists in geothermal domain. And of course, some conclusions. So, in general, as a geologist, we deal with understanding and representing the Earth history and also the subsurface features. There are a lot of ways in which us as geologists or geoscientists can contribute to the industry. Our tasks are related to estimating the depth, the quality, or extensions of deposit which have different potential, either hydrocarbon or now geothermal as well. Also CCS, for example. I would like to emphasize that also our responsibilities start before the extraction of the resource. So we are also dealing with the estimation of oil and also try to see the potential of different areas. We are also, I mean, during all the steps of developing a field or a potential field, we are offering a great support for decision making, and we are trying to make priorities and to see which areas display more potential and also try to find the best technologies in order to produce the resources as sustainable as possible, no matter the resources. And we are doing this usually, so in our step of doing this, we are creating those 3D geological models, which have the scope to provide a realistic description of the geology and also about the relationship between the different geological bodies and and the structural elements of the field. And we are trying to reconstruct the surfaces and especially the volumes. In this way, we try to quantify them for the business. And we are looking also at lateral extension property variation and also thicknesses. And usually we are great. We realize this kind of models via softwares. Of course, they have some disadvantages, which tend to be because they tend to look everything from a much more mathematic perspective than geology it is, but still they demonstrate that they have a lot of many other advantages. For example, we can integrate a lot of available data, like you can see here some examples on the slide. So we can integrate the perspective of geophysicists, which are looking on seismic or gravimetry, etc. We can also integrate our information from geology, and I will detail in the upcoming slides on which data we are looking at, but also from an engineering perspective, we can see this kind of, and we can, yes, integrate. This is, I think, a word that you'll hear a lot. So we have this ability to look at all available data. We have the possibility with this kind of model to update the model when we have new data or when we have a new concept. And also we have this possibility to interrogate and to extract the information according to those needs. And by this, you will see we are talking also about calculation of volumes or different thickness maps or to quantify in real time, etc. When it's coming to data, especially from the data that we are relying on, in order to understand the geological concept, we are relying on multiple sources. So we have information that are coming from very localized or punctual areas, like when we are drilling wells and we are taking cores. And beside this, in between wells, we also have indirect data. And from this, and I'm talking about literature and published data, analog that are either done in laboratory or different studies and experiments, and also seismic, which is one of the most fundamental thing that we are using in our industry. And of course, like I've mentioned, well data, which takes into consideration either the well logs, the core, production information, and other test results. All of those data are characterized by different degrees of detail and different spatial distributions. So it's important to check every time if there are some inconsistencies or to modify during our process them in order to obtain as better information as possible. As you will see, there is a lot of information coming from a lot of disciplines, and each one of these each type of this information can be affected by some errors. Sorry. So the base of our geological model, it's actually our geological understanding, and we need every information. Of course, not every time we will have all this information available, but it is better to integrate and to check everything. So this, yeah, sorry, I think it's working slightly. Okay, yeah. When it's coming to the geological study of subsurface, we can also base our understanding on existence of direct geological data. We can take samples from the outcrop, like you'll see here an example of from Croatia, and also we can use indirect source like previous study that were performed. Why I will emphasize a lot this regional understanding is been that because except the information that is derived from seismic from wells, I'm sorry, everything tends to be supposed to it's affected by interpretation. And it is very important to have the general framework in which we are placing our, our field or our potential prospect, and to see what, I mean, we will already have some perspective. Here you'll have, for example, some information related to geothermal potential of an area from, one moment. Okay, sorry. Yes, so to go a little bit into detail, for example, once we know the tectonic history of the area that we are studying, we already know what to expect. Of course, you can also have some exception. But for example, if you know that in some specific time you have a compression and an inversion, you will expect that the layers that were affected in that times will display reverse fault, as an example. So already when looking at seismic, which sometimes might or not, might not be the best quality, we already know a specific framework, let's say. Also, at an exploration perspective, it is better to know at which layers have more potential, let's say, and in which one we can go much more into detail and dig a little bit more in order to cover and to see our scope. Uh, yes, so it's important from the beginning when we are setting up the work, besides looking at which data it is available and, I don't know, incorporate general data like well position and existing information, to look also for the previous studies which were already published. Now the wells, which are one of the most important tools that we are using to understand and to study the subsurface. So usually also when it's coming to oil and gas, but also for geothermal, we are considering all the wells that were drilled in that area, no matter if they were for exploration, for the search of hydrocarbons, or either geothermal. They display a lot of, they have various petrophysical and stratigraphic information. As you can see, I mean, during the drilling also we are recording well logs, which technically it's a detailed plot of diverse parameters compared to depth. As a classification, the logs can be seen like the ones that are recording directly when we are drilling the borehole, or immediately after that via wireline. So we are talking about raw information like gamma ray, which is showing, for example, the natural radioactivity of the rocks, or acoustic, which is showing how quickly a wave is passing through the rock itself. After that, with these well logs, which are recorded directly, the petrophysicists have the opportunity the task actually, and the opportunity to interpret them and extract even much more information based on this. Probably it will be covered in the next sessions. For example, based on the gamma ray, we can also distribute the content of shales versus sand, reservoir versus non-reservoir, or other properties like porosity, permeability, and also hydrocarbon or water saturation. As an application, beside the fact that we can see during the drilling what is the formation that we are drilling and we are trying to reach, uh, immediately after that we can use these well logs in order to correlate them across the field and to identify different horizons or faults. Also, different properties like rock composition, and to see also I don't know if you have hydrocarbon or different contacts between the fluids existing in the reservoir. Another nice example is that based on the well logs, if we analyze the values or the trend of specific well logs, we can distinguish and uh, make a characterization of the log facies. So those kind of trends a lot of times coincide with different depositional systems or environments, and will allow us as geoscientists to interpret the stratigraphic evolution of over the years. What I want to say is that every time all this information has to be interpreted together and also a little bit harmonized in order to have a reading of the evolution of those depositional systems. In order to do this, we are also looking on the course, which I will show to you later, because we need to look much more into detail. I was also mentioning that after we are drilling the well, we can integrate it in our already, let's say, concept. And usually we are doing this via well log correlation when it's coming to the well. What we are trying with the well correlation is to find analogs in all the existing wells across the field or in the area of interest. It's a necessary step for us in order to conduct this geological model and also for evaluation of volume. Yeah, I've mentioned already that we are trying to establish relations and similarities between different wells and different markers. So what we will do is to pick markers that across the field, which we consider they are correlatable. Of course, there are different criteria on which we can find those markers correlatable. The most common one that we are using in industry, it's distinguishing between reservoir versus non-reservoir. So we are trying to look on the lithostratigraphy of the drilled sequence, and we will try to find the equivalent of shale or of the sand. Also, we can use it, we can have different other criteria like chronostratigraphy, in which we are trying to integrate the information also with seismic and depositional environments. So just to see a difference here, the sands are connected in all the wells and they are considered continuous. While with the help of seismic in the background, we can see that actually not all the sands are connected and continuous. This will give us a different perspective, of course. When it's coming to well correlation, usually we are adapting. We are, first of all, on the scope of the project. Second of all, we are adapting also on the available information, because not every time we will have everything at our how to say, not everything will be available every time when it's coming to seismic and also other measurements in the well. So these log facies can also be correlated with seismic facies, but it is important to also have good quality data and to calibrate good between the well and the seismic reflection. I was also mentioning about core data and how the fact that how we can correlate also the log facies that we are seeing on the well, which tends to be to have a different resolution compared with what we are seeing in the cores. Beside this, we can also integrate when there are existing borehole image logs, which tend to be more complex log, and they are giving us much better perspective on the internal architecture and layering, and also porosity or fracture of the reservoir. You can see here. Some details. It is, of course, this is the ideal scenario in which we are having both the dynamic image recorded in the well, and after that the core characteristics in which we can see internal layering and different features, like here, regular or layered patterns. One moment. Also, beside the core and geological information, we can integrate the information that is coming from the reservoir engineers, and analyzing the production data will have much better insights related to which kind of reservoir we can encounter. And here we are talking also about lithology. For example, if we have a fracture, a carbonate reservoir, and we'll know that we are producing from fracture, or actually also its metrics support it. Or we can also be aware if we have boundaries in flow, like a pinch out or maybe a fault nearby, and we can see this from the behavior of the well in production or during the test itself. Also, if we have a test, we are having direct information about which phases are in the reservoir. Are we talking about water, oil, gas, all of them, and also their characteristics? Not to mention the pressure and the temperature, which we tend to use quite a lot now, also in our search of potential geothermal projects. And I will end up with the seismic information, since it's again fundamental for extrapolating our information that is coming from the well for the rest of the field and the rest of the reservoir itself. We tend to, of course, besides seismic, we can also have additional methods like gravimetry or magnetometry, but in the conventional reservoirs, they don't tend to be used so much because they are not having this proper resolution. So we are relying much more on seismic. It helps us emphasize the structural environment, the structural and when the tectonic setting, let's say, because studying the reflectors, we can identify faults and different surfaces, as long as also discontinuities. Beside this, if the seismic is allowing, the quality of seismic is good enough, we can also study this seismic attribute. Based on the seismic attributes, we can have much more information related to the stratigraphy and the properties of the reservoir itself, like porosity and but also fluid content. And not only fluid content, but also when it's coming to petrographical content, depends. Now the workflow. First of all, I need to mention that it will be, and it is, a very iterative process, since we are trying to incorporate all the information existing, from the general information up and importing all the deviation and header and coordinates, etc., up to the structural modeling, on which is based on well log, well information, and also seismic, and the rest of the steps that you'll see here. Usually the workflow tends to be developed in two domains: in time, because we are working a lot of in seismic, but also in depth, because in the end the information that is coming from wells, it's depth related. And this is why it is very important to take into account all the characteristics of the available data and of the modeling. So we have to also to adapt this workflow to our scope. So the starting data, but even so, the starting data, let's say the starting steps are the same. We are starting with seismic and with the well data and try to integrate them as much as possible. Those two domains that I was telling to you about time, because we are looking at seismic and depth, even if they look distinct, they are connected from the beginning. So usually we are using a lot, we are trying to find this time depth conversion in order to convert our models. Of course, the result of the model depends also on our scope and on the available data and our time. But in general, we are doing it in order to evaluate the resource, in order to know where to place wells and to find the proper location. Also, if it is possible, a reservoir simulation, and together with an integrated team to find the best technologies and the best development plan for an existing field. And yeah, a little bit more about structural modeling. I think I didn't add the slide. It was about the fact that, like I've mentioned, it was relying on the information both from seismic and wells. What we are doing is to interpret first the horizon and the faults, and after that to convert those horizon and faults into depth using TDR. And we are trying to optimize the constraint and to derive everything from the seismic interpretation. And after that, we are trying to connect it with the well markers and also the structural maps and the thickness map that we are doing. During all this process, the model tends to go under various control and QC data and refinement and modification. This is why the teamwork it's essential, because it's everything tends to be quite complex. Now, how can we do this and how can we apply to all our knowledge to geothermal? First of all, I will take a little bit of time and try to classify a little bit the geothermal. I know that some of the information you already know, but it is important to have it again restructured, at least for me. So from my perspective as a geoscience, I tend to classify the geothermal energy based on the resource itself. So I'm talking about how we are dealing and how we are having this resource. And first the type, let's say, of the reservoir. Are we talking about high temperatures, high enthalpy resources, or are we talking to low enthalpy? Also, as a geoscience, it is very important to know the process in which the heat tends to be transferred to our reservoir in order to understand much better our reservoir. Of course, we also need to know, even if we are a geologist, what is the client need and how we will use the geothermal energy in order to adapt our criteria and our search. And this is why it's also important to know the use itself, but also the technology in which it is supposed to extract this resource. I will go a little bit into detail in the upcoming slides about everything. So related to our first classification, which is dealing much more with how to say, with our part, with subsurface. It's also this part of is this classification of the resource. I want to mention that heat refers to energy in transit, so it's we are defining it as an energy and not a property of the material. In order to measure this energy, we are using enthalpy, which is the measurement, our way of measuring it. There are multiple classifications when it's coming to enthalpy of the geothermal system, like you will see here. For the moment, it is not something very well established, but in any case, roughly, we can assume that everything which is below 150 degrees, or it depends again of the classification, uh, it is considered low enthalpy. And everything which is more than 150 degrees, we can already talk about high enthalpy. Beside this, for us it is very important to know how the heat it is transferred. The main processes are the following: conduction, which means that we have also involved some fluid. So the hot temperature, the hot body, let's say, tends to release temperature toward the colder body via the fluid movement. We will need the presence of some fluid. When it's coming to convection, the heat moves without any fluid involvement. Let's say it's a direct transfer. And radiation, it's the best example is the sun radiation that controls the Earth surface, the temperature. It's the only process which doesn't require a medium to pass through itself. Usually radiation, it's covering more, again, the shallower part, while when it's coming to subsurface and in our assessment, we are trying to look more into systems which are either conduction dominated or convection dominated. In order to do this, a very important step for us, it is to calculate the heat flow. It will give us the best perspective in order to delimitate the areas with the biggest potential. So it is done also regionally across the globe, but also it's our first step into looking into potential areas and reservoir. What it is happening is that from the warmer areas toward the colder areas, every time will be this transfer of heat. You'll see here the average value. The average value at the globe or at the planet level, it's 87, but still anomalies occur. In order to determine this parameter, the heat flow, we are using the Fourier law. You will see here what it is considering. It's the fact that the heat flow, it's depending on the thermal conductivity of the rock or of the material, and also it's directly depending on the geothermal gradient. The minus from the front, it's showing that every time the heat will be in the it will be oriented from the hot body toward the cold body. Actually, it's every time a positive parameter. So in the upcoming slides, I will detail a little bit the thermal conductivity and the geothermal gradient, since they are the main parameters which are defining the heat flow itself. Now, the first one in the equation was actually the thermal conductivity. It's actually describing how well the heat is conducted through a material, and the symbol for it's either K or lambda. Of course, there are different ranges, and it depends a lot also on the rock or on the material. In general, we can measure the thermal conductivity in a laboratory on rock samples, but still there are some challenges when it's coming to this thing. First of all, because the dry rocks tend to have lower thermal conductivity than the wet samples, and it's we are trying to preserve the fluid content in the pore of the rock as better as possible, and it's also, of course, a matter of representativeness of the sample across the well. But beside those measurements, there are also different approaches in which we can estimate the thermal conductivity in a well or at a specific depth. In general, we are using as a first criteria, let's say, the lithology. It is very important, the arrangement during the molecules, and also it's also important how the how the rock itself, it's uh, from what it is constituted, from which minerals it is formed, and also the arrangement of the minerals. But you can see here some examples how it is varying. You can also, usually when we do not have information that is coming directly from the lab, we are also going at the analog again and different studies, and trying to use the information that it's already existing from different experiments, let's say. What I wanted to mention is that the thermal conductivity, not only that it's impacted by the lithology and also by the porosity of the rock, but also we have noticed that tends to be influenced by pressure and temperature. And this is why sometimes you will see here, for example, different ranges. Usually, of course, there are multiple studies that go into detail, and you can make the assessment when we know more about the area. But as a starting point, every time it is a good approach to take the average, the mean values existing in literature. For me, I think it's quite an important parameter. So of course we will not be able to predict in the most accurate way, but even so, it is better to do our best in order to do it, because it is one of the most important. It's a key variable in the end in the thermal modeling. So it controls a lot the temperature in the sedimentary basins. About the geothermal gradient, I think you already know. It refers to the variation of temperature with depth. In general, also it is good to connect it to our geological understanding, because different tectonic settings and different processes can impact a lot the geothermal anomalies. So, for example, in normal conditions, like we see here, the gradient tends to increase linearly with depth. But in specific geological situations, we will have different response of the temperature. Of course, also at a global scale, we can connect it also to big processes, like exactly where we have the most potential for geothermal usage, especially for electric. It is where it's the ring of fire. So we are literally correlating directly the geology with the potential of geothermal. Also, on a smaller case, for example, at the basin scale, we can explain the anomalies via multiple processes. So you'll see here across Europe, which tends to have an average geothermal gradient, that there are localized areas which display much more potential. Of course, Italy, which is the pioneer, Iceland, France, and of course, all the countries in the Pannonian Basin. Usually, this is explained by a thinning of lithosphere when the Pannonian Basin was formed, and we have this impact of heat, of a higher heat flow. So this is why I'm coming back to the regional and understanding, and how we can connect it, and how we can use it not only from oil and gas, but also for geothermal searching. In order to see, to see what is the geothermal gradient and to confirm it, not only with the regional understanding, we can derive the data directly from the wells. So from the wells, we can take the temperature that is existing either in the production test after some time when the well was already drilled and some tests were done, or also during the drilling. The last one, where I was referring to the drilling, I was referring to the information that is coming from drilling. It's that it needs to be taken with cautiousness. It's because during drilling we tend to cold a little bit area next to the well with the drilling mud, but still some correction exists. Even so, we can do it in order to have an idea, a glimpse, and to confirm the geothermal gradient. So taking those two, geothermal gradient and thermal conductivity, we already can we can use it in order to determine the heat flow generation and to create maps on a regional scale. I was also referring about the fact that we need not only to understand the subsurface processes, but we also need to know how we intend to use the geothermal. There are multiple technologies, multiple usage, and every time we need also to how to say to be connected to the client need this time. So we can use geothermal in multiple ways. You can use via heat pumps, like one moment, like heat pumps, which are we are tapping only the shallower levels. In this case, the geological input it's not so uh, detailed since we are tapping constant values very close to the surface. We can also use the geothermal directly for heat. And we are doing this via hydrothermal system, an injection well and a producing well. Of course, it will be needed our help in order to delineate possible reservoirs, continuity, quality, depth, etc. The last case it is, let's say when it's coming to direct use, it's also referring to the springs and hot water that is coming directly on the surface via other paths like fractures in the rocks, etc. Also, when it's coming to hydrothermal, I forgot to mention, we can use it also for electricity. But in general, this means that we are tapping either higher depths and reservoirs which are deeper or different anomalies, like I was showing to you different location in the world. Besides the conventional geothermal system in which we are using the system exactly the way it is, there are also multiple systems like enhanced geothermal system in which we are trying to create different path for the fluid to flow, let's say. So what we are doing is to try to frac the reservoir in order to increase the permeability, let's say, or the yes, the productivity actually of the system. And lately, other systems were also developed, like closed loop system, in which two wells are drilled, and we are only circulating the water. And we, in this case, we are relying entirely on on the conduction and not on the convection and fluids, like in the previous examples. Why I was saying this is because you will see, and I guess you already had a glimpse, that beside the fact that we tend to use the information that is coming from well and from wells and seismic, and to use the same workflows, let's say, we are trying to see what are the prospects, what is the quality, what is the depth, where we can place wells, similar like in oil and gas. We can I mean we can also apply our skills, and depending, and we can need to adapt them on different technologies. Also, we have more or less the same requirement when you can estimate we need to estimate the resource and the reserve, and also to assess the uncertainties when we are doing this. And of course, we have to compile to different standards and guidelines. I was talking about the fact that we need to adapt our skills also to the technology that will be used. So, for example, when it's coming to the classical hydrothermal system, which in which the exploitation tend to be done via two wells, the injection and the production. Of course, the geothermal system is controlled very much by the geology. So we need to understand it quite well. Because as a requirement, you will see on the slide, we need also reservoir in order to accumulate the heat. like the aquifer, we need a source of heat, but we also need a barrier, a seal to hold the accumulated heat. Also, it is important to, like I mentioned, to see what it is the extension and where we have barriers in flow, what is the charging of the aquifer, if it has a supply or not, how quickly is the supply, and to know, for example, uh, yeah, how extended it is. More or less, the modeling, it's quite similar to what we used to do in oil and gas. We are looking on seismic, try to interpret the faults in the horizon, and after that trying to look much more into the properties of the reservoir itself. Because also beside the existing of the reservoir, we need to take into consideration also the capacity of the rock itself to permit the fluid to flow. So we also need to look on the porosity and permeability, very similar to an oil and gas reservoir for us. And this is why I was also showing before the workflow itself, because it tends to be very similar, integrating all the data in order to see where we have the potential and what is the quality of the system. In general, in order to calculate the resource and also in the reserve, we are doing it via softwares. We are considering not only the geological parameters, but this time also the thermal properties, like of the thermal properties of the rock and of the water. Here it is an example of the volumetric calculation. Again, usually tends to be calculated via software. But just to have an idea, it also consider the extension, the depth, the thickness, and also the water saturation and the porosity and porosity. Another example is a software here that we are using internally, for example, TNO, in which we put the parameters and we have results. But of course, this is not the only software. There are multiple ways in which and multiple softwares in which the resource can be assessed. I was also mentioning about the closed loop systems in which we are not relying so much on the presence and on the parameters of the reservoir rock, because what they are doing is to connect wells, to connect two drilled wells, and only to circulate the water between the wells that are connected. In this way, the water will be only heated by the rock itself without relying on the aquifer. Here it's also another example on how we are calculating. Again, it tends to be calculated with the software, but only to have an idea about the mathematics behind and how it is using the mass flow rate this time, and not the permeability, not the porosity, and also the capacity of the fluid, and of course, like all the system, consider the temperature as well. So as a conclusion, the geological model tends to be crucial, both in oil and gas, but also for geothermal, because they are giving us the ability, the opportunity to integrate the existing data and to update the model every time we have new information, but also to extract the information that we have. It is also important, and maybe I didn't mention so much, that it's better to, our scope is to make the data as realistic as possible. So a geological understanding, it's crucial. We have to consider from the logs and the existing structure. Like I've mentioned, there are several similarities, and all the information has to be integrated and harmonized. Don't forget, we are talking about different scales, and it is important to QC every time we are doing this. So this is why it is important to understand all the available data and what can do, and also its limitation, because actually every data is coming also with its own limitation, and to integrate with our team as much as possible in order to provide models as accurate as they can be. So if you have any other questions from now on, if you prefer to go much more into detail, let me know.
Well, thank you so much, Anna. That was fantastic. And, something that I noted in your biography but did not say at the beginning of the session is that you're very passionate about mentoring geologists and geoscientists. And so thank you very much for being here and sharing your experiences at OMV because you have such a diverse background. And, you're really bringing it all together. So thank you for that. We've got some great questions in the chat, which we'll go ahead and go through, but something I wanted to, again, thank you for is the fact that you brought in the geoscience and the engineering interdisciplinary aspects, but you also touched on things that are going to be really important for this challenge, like the heat flow classification, or how we calculate that, then the resource classification things, and how dynamic these geothermal systems are. So thanks for making sure that we touch on that beyond just building the geological model that we'll be using for this. So much appreciated. So we've got a few questions in the chat here. So how about we go ahead and go through those, and we'll feel free, anybody else, to continue to post your questions or comments in the chat while we're discussing here. So there was a question here that I'll just mention. Thomas asked about some more detailed questions about petrophysics logs. Now, Anna, you did touch on the logs at the beginning and the types of logs that we can integrate. I'll just mention that we are having a detailed session on petrophysics next week. So that will likely be covered. But Anna, just in case you had anything to add, it sounds like any logs you can get your hands on are probably useful for integrating. But would you like to comment on any of those, any other useful logs that are used in that space, this space?
Now, of course, to be honest, like you've mentioned, all the logs are useful, but I will be honest, not every time it is chosen in the industry to acquire all the possible logs. In general, we are relying quite a lot of gamma ray because it will help us delimitate quite a lot what is reservoir versus non-reservoir, and resistivity, which also tends to be a basic, let's say, log that it is acquired during drilling. I also had the experience to work sometimes only with vintage log like SP. So what I would, of course, I would use all of them and take the information as much as possible, but unfortunately, will not have every time this. Also, I think it is very important to consider that we need at least an acoustic or maybe a density in case we do not have a VSP, which will be recording during drilling. Density or acoustic will help us, or maybe the petrophysicists and the seismic guys, to correlate more the depth of the well with the seismic. So I think it's quite useful to have those logs as well.
Fantastic.
Yeah, I just realized now that actually I did not cover the part of check shot of ESP, in which we try to measure also the time itself in the well. So we will be able after that to connect as much as accurate the seismic and to make this conversion with the wells. In case of something, again, we can do something with density and more acoustic, etc.
Excellent point. Next question. We have Liz asking if there's any resources you can recommend around understanding. You really touched on a lot on the regional, like having a really good regional understanding to kind of set the scene and hang your hat on more detailed areas that you're looking at. And so Liz asked if you have any recommendations for the basin, I believe the basin that we'll be working in here, the Panionian Basin. Any recommendations on reading material? It's kind of putting you on the spot a bit,
First of
but
all, no. First of all, I think that I would go, even if you're not a geologist from the beginning, you can go every time for each country for its own site. Because, for example, what I was showing to you also about Croatia was taken from their site. And from there, we can do a much better, let's say, a much detailed dig. I can also provide, in case of something, you can contact me because looked a little bit also on the area. I was curious and I can provide some information, but you can go from big lines, go at the site of the national agency of each country. And when you are opening some of their materials, go to the bibliography, for example, and try to find. This is only what I'm doing for several projects, and that was my approach. But for this one, of course, I can also send you materials.
Oh, that's wonderful. If somebody did want to reach out to you, is LinkedIn the best place to message you?
Yes, and I can also drop my email account in case
Okay.
of something.
Perfect. All right. Well, thank you very much for that. Now, this Thomas asked a question about enthalpy, and it was just before you had put up a slide on, I think it was your resource classification slide. So that may have been answered. But Thomas asked about first about enthalpy classification, that one that I think it ended up being 150 maybe, where you had a cutoff. What that was based on? Is that a phase change
This is
or?
also, again difficult because there are multiple classification, and I think it
Yeah.
was easier for us because roughly after 150 you can already start to look for electricity, which tends to be more economical. And this is why internally, for example, we consider this, but we are not very keen on. Of course, depending on enthalpy, the conversion from heat to electricity might be better. So we already know that, and probably it will be covered in the next session, that
Mhm.
you have to look for higher temperatures. And we are more using it like to make this difference, when we can use direct heat and when we
Mhm.
can also for electricity. But again, don't take it to, well, let's say, like a fixed value.
Yeah,
Like you said, multiple
absolutely. And I think this question that Thomas also asked might be better for when we have some reservoir engineers, but if you have any comments on running, looks like going ahead and running sort of more dynamic models after the fact. So composition or black oil simulator kind of models. Probably when you're running some of the flow modeling after the fact, maybe. I'm also not an engineer, I'm a geologist, but yeah, any comments on that? I know we have
What
there's go
Yeah,
ahead,
I
sorry.
think it will be better covered in the next session. What I can do
Perfect. Yeah.
what I can mention is the fact that we do not tend to go into complicated simulation for geothermal because first of all, a lot of time you are considering a single phase and not multiple phases. So, and you
Hmm.
are also eliminating a lot of parameters like the viscosity itself or other parameters. So the softwares that tend to be used rely much more only on these mm,
Hmm.
simple parameters, but maybe it is better to double check with other reservoir engineers. This is only like I've mentioned, it's better to integrate from with your team, and this is what I understood from my uh,
Hmm.
which is dealing with this.
Yeah, absolutely. Yeah, and this question actually came up in our last session too. And now I know that you work in the low carbon business division, so you're probably touching or at least being exposed to things other than geothermal at OMV that fall into the kind of energy transition bucket. But any comments on using CO2 as a working fluid inside of a system? Do you have any experience with that or any comments? I know some of that work is kind of ongoing, but any thoughts on that?
We did not discard it for the moment,
Yeah.
but also we have noticed that from our initial simulation, it was not a big improvement in the efficiency of the system, or at least in the case that we considered. So for the moment, we considered water still.
Hmm. Yeah, absolutely. So then we have a question here about geochemistry. So, my understanding, like geochemistry can be another important piece of data inside of a geothermal system. So I think this question is around helping you understand the system in general and the heat source and lots of different things. So any comments on geochemistry and how that plays into the model of the system?
Yes, it is very, how to say, it's a subject that we are integrating as much as possible, because there are also times when the geochemistry can actually lead to the closure of the project. So we are talking first of all about high mineralization, but we also we encounter a project in which we didn't have any chance then to drop it out, because we were also encounter H2S, which might be very let's say it might be potential dangerous for environment and for the wells and for everyone. So usually, of course, when you are having information from hydrocarbon areas, you can already correlate and you already know. If not, in any case, an exploration well will be drilled, and this is one of the main focus to acquire information related to the geochemistry of the water.
Mm-hmm. Fantastic. Um, so I think this is sort of the last technical question here is around um, induced seismicity or during during the development of a system, injection, production, the effect on seismicity in the area. So any
Yes.
comments on that?
Yes, of course, it is part of our job. 100%, I'm not sure if you'll ever be sure, but we are trying to mitigate as much as possible the risk. And we are doing this with geomechanical studies, and also with seismic. And we are trying also to identify, beside the faults and fracture system, there are multiple technologies on which we are working on, including installing monitoring sensors in the wells. But at the beginning of the project, at least you can do a geomechanical study, regional or even better localized, and to acquire seismic in order to see the fault and fracture propagation.
Mhm.
Because, of course,
Okay.
that you have to consider, sorry for it, it's that thermal compared to oil and gas has to be drilled very close to the city, very close to the off-takers. So for us, from not only from a technical perspective, but also from social perspective, it is very important to consider this part.
Hmm.
We will not start a project without having at least a regional understanding of the geomechanical study.
Yeah, absolutely. Yeah, and then communicating with the public and making everybody
Yeah.
aware of that it's safe and that the work has been done to kind of prove that out. So yeah, that's fantastic.
The good thing
Uh,
is that, for example, for us, and sorry, we are still in the process of looking for closed loop system, but in this case, they tend to be a little bit safer. And it was one criteria that we consider when we started to look for them, compared with other technologies like enhanced geothermal system in which we are fracking. I think everything can be mitigated as long as the homework is well done, let's say, and we have a proper understanding.
yeah, yeah, no, that makes complete sense. So I think we've got and that answered all the questions. There's been some great comments as well. People just suggesting some resources themselves and just commenting on other people's questions here. So recommend everybody to check out the chat there for some extra resources. But yeah, I think if there's no other questions, Anna, I was trying to think of a witty way to end this this session, but I would say, what is your as a geologist who worked in oil and gas, you're now working quite extensively as an expert geoscientist in this area. What would be your number one sort of tip to a geologist who's kind of maybe coming into this as a brand new geothermal geologist or maybe coming from oil and gas? Do you have any kind of big takeaway that you would love to say? Like,
Mhm.
I don't know.
Good question. Well, I would say that, of course, the geothermal was around for so many years, let's say, since the Romans up to 1900 or so. But still, I think we are still in the process of implementing, of regulating. So it's better to keep your pioneering spirit and to be curious and to look for opportunities, like, let's say, in terms of technology, in terms of location, and in terms of potential areas. In general, I think every time it's better to be curious and to be open-minded as much as possible. I think that would be my takeaway after making this shift, you know.
Absolutely. It's like it's really exciting and very collaborative, which is one of the best things about working in the energy industry, I think. So, yeah.
In general, you're right. In general, in industry itself, not only in geothermal, it's
Mhm.
better to adapt and to be as curious as possible and open.
Exactly. Well, Anna, thank you so much for being here. Your talk was excellent. It was multifaceted. You covered so much. You gave everybody a great baseline for jumping into the hackathon from a geoscience perspective. Once again, I'll remind everyone that this session was recorded and we'll be posting it on Discord, I believe, at the weekend. But keep your eye on that. I'm just going to go ahead and share my screen one more time, just because I wanted to remind everybody um, of the sessions that we have coming up next. So we have just had Anna's talk here on the geology basics. Next week, we're going to have that petrophysics talk that we mentioned at the beginning. Um, and then we're going to move on to some of the kind of machine learning pieces, building the models, talking about heat flow quantification. That's going to go all the way until November 15th. So you can find this bootcamp schedule on our GeoHackathon website. Highly recommend you go there, check it out, and join Discord. You should have received those invites. If you have any questions, you can always reach out to the contact on this page and you'll get one of us to help out. Um, but other than that, I'm just going to stop sharing here. So yeah, once again, I'd like to thank, really like to thank Anna for this talk today. It was fantastic. Really appreciate your time, your energy, and all the hard work that went into it. And I hope everybody enjoyed it as much as we did. Any questions or concerns? It sounds like Anna is open to being reached out to on LinkedIn, or she may post her email address here in the chat. So feel free to reach out. But otherwise, I would say that we'll look forward to seeing you in the next session. The last thing I just wanted to mention was to thank everyone involved in the boot camp for being here. We have a number of sponsors that are involved in the boot camp. And I'll just share my screen one more time because they're listed here. So thanks again to our wonderful sponsors. And yeah, I'll just close out this session and thank you again. And if I can say thank you one more time, thanks everyone. And
Thank you for meeting as well.
have a really
Nice to meet
fantastic
you.
rest of your day. Okay, bye-bye.